All right, so we're back here for part two, and what we're going to do here, we're on the back of this sheet, we're going to summarize. There's three main ideas that we're going to talk about here. So number one is going to be the hypotheses. Okay, there's more than one hypothesis. We always start with what we call the null, and that's H naught. The hypotheses are always going to deal with the true proportion or the true mean. They're always going to be for a parameter. So H naught, we will always say that mu or P are equal to some, what we call a null value. It could be a proportion, some value, some number. This is always a parameter. Now we will be using sample means and sample proportions to come up with our p-value, but our hypotheses are for the true population parameter. So there's the null, H naught, and then there's the alternative, which is H sub A, so A for alternative. So if we claim that the mean, the true mean, or the true proportion are equal to something, in the alternative, we're going to say that the true mean or the true proportion are not equal to this. Now, we might say that they are less than the null value. We may be trying to show that. We may be trying to show that they are greater than the null value, or we may be trying to show that they're just not equal to the null value. So if our null hypothesis is that these equal something, then the alternative is that they don't equal that. Okay, and again, we can be more specific. Some questions will ask just for less than, just for greater than, or not equal to. The second thing that's really important here is what we call the p-value. And again, this is the probability assuming that the null is true. Assuming that the null is true, it's the probability of getting a value. Now this would be our sample proportion or sample mean. This is where we're testing the probability, assuming that the null hypothesis is true, of getting a value, sample P, sample proportion or sample mean, as extreme or more extreme purely by chance. So it's the probability, assuming the null hypothesis is true, of getting a value as extreme or more extreme purely by chance. Now, again, what does that mean? Well, going back to our example here, when we run our simulation, and in the real scenario, 5 out of 10 of the people chosen to be laid off happened to be female. When we ran our simulation, how often did that happen? How likely was it for that to actually be the case? Now again, as extreme means equal to this or more extreme. More extreme would have been if there was a higher proportion of females in our each sample proportion, okay? So that's what we're talking about here. As extreme or more extreme purely by chance. How likely is it for this to really happen if it's just being done by chance? And then the last thing here is the way we make our conclusion. And the way we're going to say this, just like with confidence intervals where we're very specific with our wording, when we say we are 95% confident that the interval from here to here captures the true proportion, and so on and so on. Here we are going to say we either reject or we fail to reject the null hypothesis. You'll notice that we're not accepting. When we say we fail to reject the null hypothesis, it doesn't mean that we're accepting it. It just means we don't have enough information to reject it. And then we say there is or is not convincing evidence of the alternative. So for the problem that we did on the front, we failed to reject the null hypothesis. We didn't have enough information. There was not convincing evidence of the alternative hypothesis that there was gender discrimination that took place. Now, the way that we're going to know this is we're going to use the p-value, which is a probability, okay, it's a number. If the p-value is less than alpha, this is the significance level. If the p-value is less than alpha, then our results are significant. If our p-value is greater than or equal to our significance level, then our results are not significant. Now, the idea of significant is we're saying how likely was it for us to get our values? If our probability of getting something by chance is so low, it's so unlikely to happen, then that means this is significant, what we found, and we will reject the null hypothesis. There will be evidence to support our claim, again on the front, of gender discrimination. But if the probability is not below whatever that level is that we're trying to attain, we're not going to be able to say that the results are significant. We will not be able to reject the null hypothesis. Now, alpha is going to represent a number, significance level, and they can change. The most common one is typically 0.05. And if that seems a little bit familiar to you, when we talked about confidence levels, the one that we typically are going to use is 95%. And you might say, oh, 95% and 0.05, those are actually related to each other because they add up to 1. And that's something that we will get to. But yes, there is a relationship between that. All right, that is the end of part 2. So go to part 3 and we'll do one more example.